Hello everyone and welcome to today's live stream where I've, thanks to the developers, got the physics solver build of Blender 5.0 working. Now I do need to state that this is an experimental build. The dev said that this is a playground to test different solvers and that, I forget what their plans are with this. I don't know if any of this is going to actually be merged into 5.0, but just for an experiment, this is looking very nice. This is using the new bundles and closures, I think closures for the most part here, or bundles, yeah, as well, to group different, data types and all that, which we'll get into. I don't fully understand all of this, but it is quite interesting to see how it works, because there are quite a few solvers. There are multiple. I think there's Bullet, Jolt, and Box2D, and maybe one more. I forget, but in this demo that I downloaded from the PR, which I should link in the chat, I had to build this version myself using command prompt and all that, because apparently the main, the BlenderBot build is still not working on Windows main, only ARM64 and maybe Linux. But there's a link to the PR if you want to go and take a look at it. So here we can see that this is using Box2D, which, as I assume, is only 2D. But we can see some interesting behaviors here. Let's see. Bundles and closures have been merged into 5.0 yesterday. Yes, I'm not sure if that was merged into this one just yet. I think this one is a day or two behind the main build. But yes, bundles, closures, and I believe the socket types are now in main, but right now I have them enabled in the experimental features. So with this setup, we can see that we have a grid of UV spheres that are instanced, and then they're turned into rigid bodies with a sphere shape, which right now the options that we have are box sphere, convex hull. Their type is dynamic, static, and animated, friction, bounciness, and all that. Then for the ground, it's just a cube converted into an instance, transformed, and then turned into a rigid body with a box, and all that good stuff. It's set to static. And then here we have cube, geometry to an instance, but this one is animated, as we can see here, and then it switches to dynamic after a certain point in time. So if we play the simulation again, we can see that this rotates, no collision happens until a certain point where physics automatically become enabled, and then the plane just falls down, and all that happens as it should. So that's very cool. I still want to figure out, if this is field compatible. I'm not entirely sure, because it looks like these are... Oh, wait, no, these are not singular values. Okay. I'm still a bit unfamiliar with bundles. I'm assuming that my brain, again, I'm still figuring this out. I just got the build working. I assume that this is store named attribute in a sense, but it works more with... No, maybe that's not a good way of thinking about it. It basically puts all this into just that's the best way to think about it. And then you can access the parts by their names. So in this case, the data goes into there and then it gets passed into here, which this at the moment is a black box as far as I know. I can't go inside of it, so I'm assuming that this data is kind of hard-coded, it's just instances, collision shape, motion type, and all that, which is good. That's what I expect. And then out here, gather bundle geometries. That seems to be hard-coded as well, even though, let's go into utilities. So bundle, yeah, gather bundle geometries. So that one seems to be hard-coded as well. There we go. Even though I should probably, with bundles, I should be able to extract that. Separate bundle, put that into there, and oh, it automatically does that. Nice. Again, still very new to this. I need to fully, understand it. But yes, a couple of things. We can change the collisions and all this on the fly. So if we go and reset the cache, and then change it so that this is now a box, we can see that the shape has changed a little bit. And if we go and change the object to be a cube, it happens live. Now, here's the fun thing about Blender. The cube is 1 meter in size, while the default cube is 2 meters. Because there's radius and then this is diameter. It's fun. I really wish the default cube was 1 meter to match Minecraft, But anyway, yes, here we can see that with cubes, it just works beautifully. Look how nice that's going. My old rigid body system would not be able to deal with that whatsoever. Let's turn down the solver steps, and as we can see, with just one step, it's still fairly stable. Let's try it with just one step and one sub-step. Okay, still stable, a bit spongy though, so let's go and turn this back up. It's looking quite good. I am quite happy with this. Now, there are more things that I need to try because there is the Jolt and Bullet. But we will try it out. I want to try something else here. Because I'm assuming there's gravity, but I don't know where that would be. Or is the gravity hard-coded in Box 2D? So is this experimental features in 5.0 or native? This is a custom build that the devs are playing around with. So again, this is not in main 5.0, it's not an experimental feature, it's in its own separate build for the devs to play around with, see what works, what doesn't, and then maybe this can become a thing in Blender, whatever version, because I'm optimistic, but I would not expect all of this in 5.0. Now, I know they're, like, with the hair simulation, they're looking into that, but I'm not sure. Not sure. But since we have the build, we can use it. Like, since I built the build, I now have that in my builds folder, so now that's saved. So that if I need it in the future, I can just go and use it however I want. Let's go and turn the friction up to 100%, bounciness down to 0. We can see that that's working quite well. Like, look how solid that is. Even when they're being clipped and all that, that's working very, very well. Okay. Let's see, do closures have a green border zone for you all? Well, this build is a bit... Let's see, let's go and get a closure. Okay, okay, it has a green border right now. I know they're playing around with the colors. I think this might not be brown in the future, but I have not kept up to date with that. Okay. Let me go and switch to the other demos that they have, and I do plan on... Whoops, wrong one. I do plan on playing around, and let's see. Let's go to the hair solver next. Let's go to the parts that I don't understand all too much, and then we'll go to the stuff where I can actually play around with. So the devs are playing around with actual hair solvers, as we can see here. Yep, they're playing around with that, and it seems like it's working pretty well. I mean, the constraints look solid. Those look like wires attached to the head. That seems good. But there are a few things. What was it? Here, this is missing a few little thingies and all that. But it seems like, I forget if this is Jolt. Wait, what solver is this running? Separate, where is the, okay. This is using XPBD, which this has rotation attributes inside, which apparently those were broken, but they fixed it. So these should be running quite well. So if that keeps going, we should have something pretty solid in the near future. There we go. And here's the deform curves on surface node, which, yeah, that's still a black box. But here, what if I were to just, wait, this won't work because of, oh, right, because it's kind of object parented in a sense. But we can see that works, and that works well. Let's see what else I can play around with. So we have the wind force, which we can enable. Wait a minute, is that... that's for cloth, but if we turn off the filter... Yeah, I don't know how the filter works, specifically. Interesting. But there, we can make it so that there is a wind force going around. That's the direction, and then that's the intensity. Okay. This will be quite cool. But another thing we can see is that the monkey hair, this is actually rendered, while this one, since it's on an object data type, the rendering does not work, which is unfortunate. I know they were playing around with the curve rendering, so maybe that can be... Well, that's more of an object data type thing, so... Let's see. Can you make a tutorial on how to understand geometry nodes? I have quite a few. Let's see. I can't wait for the moment they'll convert default modifiers to geometry nodes. That's the weird thing, because I want the ability to make my own modifiers with geometry nodes. But the default modifiers, I'm still okay with them just existing. You know, they've been there for over a decade, and it's just like, you know what? I think it's fine that they're just there, just constants in the universe. I think that's good. Why are you shouting? Now the microphone's still very much into the green, even when I'm talking directly in the camera. Microphone, not camera. But I think your volume might just be a little bit too high. Please correct me if I'm wrong. But yes. So, pair dynamics are on the menu again. Let's see. There we go. There we go. Okay. With that, all that is fine. There's a drag force, a target force, and then the rigid bodies, which I do not understand just yet. But let's go and play around with the Jolt test. So file, open recent, let's go over to, or XPBD or Jolt, which one? Let's go to Jolt and then we'll play around with XPBD. Okay. So since the devs have put in multiple solvers into this, we should see, yep, there's stuff going around. Let me go and turn on cavity because it's going to world so that we can actually so we can see what's going on. There we go. Oh, that actually brings up something that I want to test. Oh my gosh. Let's go and put in some frames into here so that I can see what's going on. Delete everything that is unnecessary. Okay, lines and boxes, that's all it is. Let's see, select those, okay, that's a thing. Yeah, I need to get used to this. It is somewhat reminding me of Embergen, even though I have not used that in a while. With the, you just attach things to the solver and then they do the thingy. But yeah, there's a lot of interesting stuff happening right here. Yeah, I still don't fully understand it. So, combine bundle. And then we have that force right there, which I assume is just a test. So many... Yeah, this is... Oh, gosh. So we disable that. Okay, no, that's fine. So there's a force going to this target object right here. Let me go and move this. There we go. Oh, wait. Was that a new UI thing right there? Oh. It's no longer super snappy. That's interesting. Ooh, I kind of like that. So we can move this around, and in theory, yep, that'll just go over there and do all that. I also want to check, because I tried setting materials, but it did not seem to take. Let's go and use a set material node. It should work out just fine because I have Vulkan. Yep, there we go. Enabled. Let's go and set that to be that. Viewport display. Let's go and do that there. Set that to be there. Now, I don't really expect this to work. Yeah. Nope. No. GF. Move that out of there. So materials seem to not be connected here. But we'll have to play around with that in the near future. But yeah, here we can see a soft body actually interacting with the rigid body physics. Again, this is using the Jolt solver, which I believe was used in the game Horizon Zero Dawn and several others, but I'm not entirely sure. But I would assume... I would have to go and double check that. So here we can make it, if I set it to be negative, they'll move away, towards, it'll do that. Away and towards, away and towards. But I also want to check what happens if I change this to be static. Ah, fun. Interesting stuff happens. Animated. We should be able to move these around. Let's see, animated box. So with animated, it should be able to move around unless... World... No, the world goes into there, so that should be fine. Maybe I'm just looking at the wrong thing. Maybe it needs to be like scene time based. Let's go and try this out. Huh. I am probably missing something very obvious, so yeah. Scaling that. Okay. Oh, maybe it just runs differently to Box 2D because I'm just like, oh yeah, it's another solver, but yeah, they don't all work the same way. That would be weird if it did. Okay, let's go back to dynamic so that those can move. That one is convex hull, dynamic. Which one was that again? Ah, that was the cone, right. So we have that, that, and that. So how would I go and freeze the meshes? So that's a soft body. The stiffness is like that. Set the bend to be like this. Yeah, these, oh, whoa, what the heck was that? Ah. Stretch would be 0, bend would be 1. Okay. Oh, that's really interesting. Turn up the bending. Please don't crash. Oh. Or not crash, but, you know. Freak out. Okay, that's interesting. Very, 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 very interesting. Substeps, we can set that to be like 3. We can see that it's become a lot more stable. Okay, not bad, not bad. Still likes to glitch out a little bit, and then that does that. Very cool. And what are you? Just a lone cube traveling the universe. That's because gravity is like that. If we set it to be like that, it would fall. In theory. Yep. Just goes. Okay. Let's move you back to the origin of the world. Bring you up. Bring you over to. Oh, right. It's not in the same simulation, right? I forget that there is not a general world for all these to live in. Unless it's like inside of the same object. So we have that, that, and that. We have force, which that's just a force going straight down most likely. So I could go and take that out because I think I only want as an attraction force. Okay, so there's still... Forces are interesting. Let me go and chop that out. Bring you back out of here. Unhide it. There's gravity, which I assume is just blender dot... Oh, wait. Blender get... Oh. Wait, what the heck is this? Okay, I do not know how that works, but I will need to figure that out. Is that just a filter? I do... Huh. Interesting. Let me take a look into there. So, oh, that's not even... Wait a minute. Oh, okay, that's a string and there are multiple... Yeah, I do not understand that. Okay, there's a lot to uncover here. A lot. Okay, but for now, let's go and have some fun with it. Let's just go and set the amount of boxes to be something stupid, like 40 by 40. And I may have just, yes, that, yeah. Let's go and give it actual space to breathe. And boom. Okay, what force is making it go haywire? Right, that one. Let's go and set that to be 0. So now we have a ton of boxes. The attraction force is disabled at this time. Though I want to check if I can make it so that the force is decided using regular math. So let's go and use a scale and all that. Also, hello to everyone in the chat. I think I spot a community developer. And, CG Matter, hello. Again, with this build, you have to build it yourself. The bot, unfortunately, tried, and the Windows version did not work. Only the ARM64. Oh, wait, we can see that the homemade attraction force is working as intended. There we go. Okay, that's good. That's good. So we can make our own custom forces without much difficulty. For some reason, I was thinking that this might be a singular value, but again, with the new socket shapes, if it looks like a 1, it's a 1. 1 value. So let me try to... That's a ground plane, but we could make it its own rigid body. Or... Let's see, where is the actual ground plane? It's a grid, and that's there. I'm gonna try to simplify this into just its most base components. So again, let's go and chop out the material, put you right into there. Okay, you're still a grid. Yep, that's that one. That is a cylinder, which is right there. Okay. That's an animated collider. Oh, okay, so it's a... Interesting. Okay. We can go and break this out of here completely. And a good thing is just trying to simplify it. Just have it as an instance animated box. Plug that into there. Good. Breaking that out of there. We can go and chop out both of you, I assume. But why does it look like gravity is still occurring? Actually, the ground plane... Okay, so the ground plane is just a rigid body. So we can break that out of there as well. Okay, I think well, let's not get ahead of ourselves. I might start understanding this very soon. So I think in theory, I would just need to have... Let me think about this. To set this up with the least amount of bundles being input into the combined bundle, I would just need 3 rigid body classes. One for static, one for dynamic, and one for animated, or in this case, only 2. Because we have 2 dynamics, so in theory, I should just be able to... But these have different settings. I'll read the chat in a second. Sorry for neglecting you all. Again. Let's see, so that one's animated. That one is static. Is there a big difference between if they're static or animated? I don't think so, so I'm just going to use a join geometry node and call it a day. So these ones are both box? Oh, okay. Don't really complain about that all too much. Let's just go and make this box really big and really thin. There we go. So is that colliding correctly? Yes, except for the box in background, which we can delete because that is unnecessary. Let's see, we have the soft body right there, and we should have another soft body somewhere around here. Right, that's that. So we have 2 soft bodies. Let's go and just combine them into one, and hopefully that doesn't ruin everything. So again, trying to do as much work in here without having to rely on a ton of those inputs. So here I'm going to get rid of soft body 0, 1. Force, we'll just put you into gravity. Test, we can remove that one, and then we just have rigid bodies, and then rigid bodies 0, 1. Could I just, I feel like I want to use like a join geometry node, but a join bundle node. Which I don't think one with the multi-input thing exists just yet. Just because this feels a little, what's the word? Constricting with the set amount being input and output. Though, they have to have labels, don't they? So I don't think there's a way around that. Let me read the chat again. You move and commentate so fluidly, it doesn't seem like this is live. Impressive. Well, that's why I don't read the chat all too often, because I'm so preoccupied in my own workflow, my own little world. But yes, this is quite fun, so I get in the zone, just like yesterday. Yes, also, special thanks to Jax Luke for fixing the build for Windows. Hopefully it wasn't a bother, because most likely, yeah, most likely someone tipped him off that I couldn't build it. Let's see, let's go and bring this over to here. Bring this over to there, bring this over to there. Let's see. The issue with default modifiers is that you can't use them inside the node tree. Right, yes, I forgot about that. It would be awesome to have the remesh modifier as a node group, for example. Yeah. Yeah, in that case, it's like, oh yeah, if we can use that inside of GeoNodes, that would be good. Let's go and bring this over to here. So again, these are our forces. So those, we basically do all of our physics inside of here. So that should be maybe last. Let's go and bring our gravity, which in this case will just be forces. Hopefully that doesn't mess around with... I don't know if the names mess things up when they're put into the solver here, which we can break this out. Let's go and ungroup. Again, we want this to be in its base form. There we go. As few node groups as possible, just so that it's not confusing for my small little brain. Okay, so we have that, that, and that. I think that's about as small as we can get it without all of the bundles in there. Okay. As a system, this isn't bad. Like, it, you know, moving around the geometry and all that can be a little bit of a headache. Oh, wait a second. This is not an instance, is it? So that one might have an issue or two. Nope, that actually seems to be working just fine. Ah, because... Okay. Wait a minute. Make an instance with origin at the geometry. Oh, okay. I think I kind of get what's going on there. So rigid bodies. So it's a... Okay, so that's a wrapper on that. Okay, and then that's a wrapper on that. So we don't want to play around with this. Do not touch this whatsoever. This one, though, we might be able to play around with that. So I think we might be able to break this out of there as well. That's rigid bodies, rigid bodies. Okay, yeah, we can go and break this out of here. Let's go and bring this out of here. We just need to convert the cone to an instance before it is to instance, geometry to instance, plug that into there, do that, bring that over to here, switch it back to a convex hull. Oh, maybe it's because it's convex hull. Let's go and try that. Let's see if it, yeah, let's see. Nope, that seems to be just fine, even in its current state, so we can go and get rid of another node group. Yay! So it seems like we're only at one level of node grouping, which is good. Maybe two? Okay, 2 levels it appears. So that's not bad. That's a simplified version. That all seems to be good. Transform geometry. We could transform instances if we so choose. Though I am wondering if we can make this another level down. Let's see. Let's read the chat again. Is it possible to run a physics sim on changing geo? Oh, hello Ashley. How's it going? Like, imagine a ball that has retracting spikes in a loop. I think that is possible currently, but I do need to play around with that. That is, oddly enough, the original reason why I made my, well, with help, made my own rigid body solver inside of geometry nodes. It didn't fully work because of collision points, but that's a story for another time. It's because I wanted to have an animated rigid body to do everything. But unfortunately, since Blender 2.8, due to dependency graph changes, updating rigid bodies just straight up broke, and it's still broken to this day. Where the only way it could update would be from a manual input from the user, as far as I know. I think I made a bug report about that maybe like 2 years ago, maybe even longer. And it's just a limitation, because the old system is dead and dying, and not actively supported, if I'm correct. Let's see. Some solvers allow it. I think with Jolt you can. Yes, I will have to change that. Let's see. Why, bro, why is Blender updating faster than I'm learning? Because people need tools. Like, you know, if Blender's gonna, you know, replace Houdini as the de facto procedural thing, which I say that as a complete joke. Blender will not replace Houdini. Houdini is still king when it comes to solvers. But since we all use Blender so much, again, Blender is my favorite program. I've been using it for so long. It's always appreciated when it becomes more powerful. And I can do more things in the program that I love and that I've contributed towards, and that has given me massive amounts of money via employment. So, it's nice. Okay, let me read the chat before I proceed with trying to animate these objects, because... Actually, wait a second. In box 2D, I think it should be possible, but I'm not sure about this one. Let me go and save this in its current state. Okay. Jax and Lucas have been experimenting with many. There is an older bolt solver, a homegrown XPBD solver, box 2D, and a newer hair solver. Okay, so there's 4 or 5 solvers in here. But they are mostly looking at how to interact with physics day and geometry nodes, not necessarily adding all those into Blender. Yep. I can't seem to find the branch on the Blender site. Is it available pre-compiled? Unfortunately, no. Here's the link to the PR. The Windows build is currently broken. The way I got this build working is that I did a just full make build via that, and it worked today. Yesterday there were some interpolation errors, but Jax fixed that this morning, and I'm very grateful because I get to play around with the new toy. But yeah, we have that should be fine. So yes, how do we go and make this all update live? So again, we have our forces, we have our rigid bodies, our collider, which is another rigid body, and this is another rigid body. That's a dynamic convex hull, and that one's a box. So we have our rigid bodies up here. That's good. Let me go and flip around these ones because I want them to be there. This will be, what is it? I mean, I could just combine bundles here, so these will just all be our rigid body. Actually, let me reset this and then try to make this ISO 1, rigid body ISO 2, chop these out of here, and then put those into there. So hopefully that'll work correctly. We can just keep combining them without it freaking out. Yes, it still works good. So we can have that right there, and then it gets plugged into there. Okay. So this is the vision that I see for this physics system. You just have your rigid bodies, your soft bodies, your forces, and I'm assuming whatever other type of main high-level thing there, those are the main ones, and then we just combine all our rigid bodies beforehand, all of our soft bodies beforehand, and all of our forces beforehand. Even though I am a little worried that if I duplicated this and then joined it, it would not work entirely as expected, but it's probably fine. Probably. So we have that, and in here we have that, and that. Okay. So as a workflow, I think this is okay. The only part where I'm kind of, I guess, somewhat iffy about it is that, like, with this we have the rotation there, which I could just go and chop that out. That's just not even necessary at the, well... let me reset that to 0. Let's try to get this, again, as simple as possible. That's fine. So I could just go and do that, Control H. There we go. Again, trying to make it look as simple as possible. Geometry to instance, put this over to here. Geometry to instance, put this right over to there. And then here, well, yeah, no, that does not need to be converted there. Okay, so that's good. That's good. We have some of them trapped underneath the world. Let's go and amend that. Let's set this to be like 5. So those are all working exactly as intended. So let's set this to be like 0.5 on all of this. Make it so that it's a little bit wider. The state, we can go and do that. Then they all combine and then do that. Okay, good. Okay, so let's go and check the render and see if anything's happening there. Let's turn on ray tracing. Let's go through the, I guess, ritual at this point. Turn this to be like that. Turn off bilateral filter. Temporal accumulation is probably fine. We can set that resolution to be 1:1, but I think that's fine. Turn off temporal reprojection because you never want that. Set the samples to be 16. Shadows, those are probably fine. It's like that. All that's good. There we go. So we have that. Let's add in a few lights just to make it look nice and pretty. And then maybe a sunlight. But I want to test if... Okay. This is something that I want to try out. So we can have cubes, but I want to see if I can make a collection of... Whoops, I want a new collection. I want a collection with just rigid bodies that I can specify. So in here, how would that work? I've done this before, but I'm forgetting how to do it. In one of the old builds, like you would have objects here with a geometry node group that would store the rigid body data, and then that collection would just be put into the solver. So here, actually, wait. Would it be a bundle? No. Maybe? No. So here would be instances, collision type, and all that. Now, that's not stored as a named attribute, so how would I even do that? I'm not sure. Because in the past, if I remember correctly, the instances would have the data just straight up stored on themselves. So I could store like the motion type, the collision type, the friction, the restitution, and all that. So I would be able to, in this case, like just a pseudo workflow, would be able to go and say to instance, geometry to instance. That would be there. I would go and realize it on one level when referencing the collection. But I would go and store all the data on here. So it would be like instance, it would be like, I don't know, restitution. We would set that to be like 0.5. Collision shape, it would be something like that. And then, yeah, I'm not sure how I could do that in here. Well, let's go and give it a go. Because I want to... Maybe I just go and plug it into there and there? Or, I don't know, maybe this can just work separate. Maybe we need to realize it by one level. I need to think. Realize instances, and I need this to just be one level, put that into there. And then we go and reference named attributes like collision shape, motion type. So then again, let's just set this to be the basis. So collision shape, we'll let that be a convex hull, so that would be 2, and then motion type dynamic, that would be 0. So that would be there and there. Friction, bounciness, we would just store those as named attributes, put that into there, so this would be friction, bounce, bounciness. The English language is so interesting. Density, plug that into there. So we could still store it on the instance level and then just translate that into there. Then maybe remove the data before it fully goes through, question mark. But for now, I think that's fine, and we can potentially plug that into there. So that would reference another collection, set it to be relative. So again, in theory, that seems to work, but since the data is not fully stored, yeah. Friction. So here you would just have your, set rigid body data. Bounciness. Let's go and put that into there. Then here it would be, what was the last one? Is there another one? Oh, density. Right. Since it has no density. There we go. Let's go and actually show these on the node group level. Again, I'm testing out the workflows for, which I guess is the goal of this build. Let's go and put that into there. So, and make these at least friction. This should be a factor. Oh, come on. 1-0. Bounciness should be, no. Why am I doing that? Add that. Factor, right. So we'll set the defaults to be 0.5. 0.5. So we have that and that. So setting those to be there, that's good. Density, default should just be 1 so that can actually affect everything instead of just being thrown into the wind. Oh, I think it needs to be a little bit more, if I had to guess. So here we can also make you, this would be rigid body setup. Let's go and set this to be RB setup. Let's go over to here, and this will be main solver. Main silver, yes, that's exactly why I intended to type. So we should see that both the cubes get pulled, even though I think their density is way too freaking high. The density is, okay, that seems to be a bit much. What is the density calculation here? Who knows, I'll just set the other ones to be 1000. I can properly look that up later. We should see as those happen, it does work as intended. Nice, mission accomplished. Let's go and see if the colors actually work as well. I'm expecting no. Yep. Exactly as planned. Materials just, or exactly as I expected, materials don't really work. Now, could I set it in post? Probably. But we can save that for later. Also, we have 50 people here. Hello, how's it going? I feel like a proper influencer now. Okay. Influencer. Don't you love that word? So nice. Such a term of endearment. Here we go. We have all that. We have our orb, and that's working as intended. The cloth seems to be holding up a bit better than well, okay, it's working about as well as I expected. Okay, so if we can't get the colors to work well, let's go and make the lights look, you know, somewhat good. Which color transform are we using? That is definitely AGX. But it works, you know. No, I prefer Filmic just because the colors look, you know, a little bit better in my opinion. But no, that works out just fine. There we go. Let's set the camera to be 1024 on both of them. And there we go. Looks like 5.0 is going to be monumental. Let me update the title. Blender 5.0 solver. This will be a custom branch. Let me try to make that a bit more clear in the title. Let's see. Wish gizmos would get updated. They're quite buggy and limited at the moment. From what I've tested, they seem to be about as advertised. Just that, let's see. Works out quite well. Okay. So setting the type. I can set the type in here. Should be able to. So, let's see. Oh, come on, buddy. Let's bring you down. Go and copy the attributes. Let's set that to be an int. So, yeah, the workflow that I had in my head is still 100% possible. You love to see it. And here, it'll just be, yeah, get data from instances. Again, you do this once, and you never have to worry about it again. It's that's good, that works. Let's go into our cube, and what I want to do is bring over the menu. Ah, dang. Actually, I could just copy this, couldn't I? Or no, just yeah. Right. So let's go and store 2 more named attributes, because the future is named attributes. I've been saying this since day 1. Named attributes are the best thing to exist. They're incredible, they're amazing, they are the best. Set it to be instance, and that'll be instance, because you can just teleport values. People have been wanting a portal node or like the select node in Touch Designer for eons, but we already have it, and it's called store named attribute. I know it's not as versatile as the other ones, it doesn't work with constants and all that, but it's still amazing. I still stand by it. Let's go and set the default to be convex hull and dynamic, so we can plug these two. Oh, come on, buddy, work with me here. There we go. Menu, we plug that into there and there. So again, this is, let me go and Control-C, Control-V the names that I already put over to here, collision shape type. There we go, and this will be motion type, plug that into there. Bing, bang, boom. Plug these into here, come on. A little bit more, so this will be shape, collision, shape. There we go, and this will be, what is it, motion type, or, yeah, motion type. Go, and let me capitalize all of these, because we wanted to make it look very nice and official in English. There we go. So yeah, that's how it's done. So we can set that to be a sphere or a box if you want it to be more efficient, or just regular. Seems like the density. Actually, how is that calculated? And actual rigid bodies in geometry nodes. Never thought I'd see the day. But again, this is a custom thingy-mabopper, you know what I mean. So you do that, you put those into the collection, you reference the collection, realize the levels by 1 so that we can get just the instances. That's fine. Because we still need to make, unfortunately, these still have to be a wrapper on the... Yeah, it needs to be 1 instance down, which isn't the worst. I mean, no, actually that's fine. It's fine that's this way. Because we can still store multiple rigid bodies on 1 object, and then referencing that, it'll just work. So yeah, ignore my previous somewhat complaint thingy. Do this so we can have a shape of any object, and we should see... Oh, you'll love to see it. The inertia tensors are working exactly as intended. Yes. Now this is a convex hull, which means that the raw collision shape is not supported just yet. We should see that this will, yeah, happens. But, yep, it works. It's nice. So I guess I can go and try out the XPBD solver, but I will save this in its current state. Look at that. EVNext is really growing on me. It seems like the speed is nice. There we go. Oh, and look at that one just orbiting. Oh, that's so fun. Yeah. Go. Let's see. Physics will come eventually to geometry nodes, but probably not 5.0. Yep. Yep. Most likely. Maybe we can build it ourselves still now. No, no shot. Jolt, like... It seems like Jolt's our only real option for that, or XPBD. I'm surprised with how performant it is. I don't think we should, because collisions like these have been happening since, well, the 2000s. Like, the performance is, again, Jolt. Like, we should expect Jolt performance. These are just a few objects in the grand scheme of things. Like, with games, they have to deal with a lot worse before they start, lagging. But this, it's good. Performance is good. I'm happy with it. Now when we do that, that's more of where it's like, oh yeah, no, that would lag in a game. So performance seems to be quite regular. There we go. Yep. There still is the bullet solver, but person behind bullet said that Jolt is the future, if I remember correctly. So it's fine. Let's see. Any chance you can get 20 times the objects just to see how fast it goes? Yep. This will probably lag, so if I say... Yeah. Oh, whoa. That's actually... I thought that was going to be a lot worse. Because a lot of these objects are still colliding, I did not give them room to breathe, which that's what you need to do if you want this to survive. Maybe not 80 on the... Wait a minute. Ah, it's rotated, that's why I was confused. Let's set that to be 20. I want to have a lot on the... There we go, okay. As we can see, while it does seem to be somewhat unstable, still working okay. And that one's just having a whale of a time doing all that. Okay. So let's have this be 160 so that we can just have an absurd count. Let's see how it works. Not bad. I would say that's pretty good. Now again, these are box solvers, or box collision shapes, so they are more efficient than convex hulls. But in this case, this is all you need. Let's do the bounciness and set it to 0. And that's with just 1 step. Oh, it is, yeah. That's not bad. That's not bad at all. So if I were to set it to be 2 steps, what kind of GPU are you running? These simulations are all on the GPU, not the CPU. No, they're all on the CPU, not the GPU. That's what I meant to say. So I'm currently running a 3060, but that does not matter at all when it comes to these collisions. It does not matter at all. The only time where the GPU comes into account is when rendering the lights here, which is cool. But yep, we have all that. Okay, so I think we've reached. Let's see, we're almost at an hour, so I guess let's go and pivot and take a look at the XPBD solver because we have not done that yet. Let's go and take a look. Okay, so this one is the simplest out of the bunch. So let's see, what do we have here? Just for simplicity's sake, I'm just going to chop all of these out of here. Okay, so we have all of that in classic fashion. I'm going to step this a little bit so that we have so that we have all these isolated before they're properly joined into the fold. We have cloth and then ropes. So that's right there. We can go and plug you into there, and then cloth's right there. We have the forces right there, which is already being combined in a kind of nested bundle. That's good. And then the ground plane is not being used. So maybe it should. Oh, that's an infinite collision plane. Let's just chop that out. Again, I want this to be as simple as possible so that my small brain can handle it. There we go. So we have all that. That's just compartmentalized, which is good. And again, I could go and just eliminate all of this. Oh wait, that's the drag force. I could just take the wind or gravity and then plug all these directly into there and it would be fine. Let's put you into there. That's good. And this is just extracting all of that, which there is the gather bundle geometries, and then we should be able to put that into there and ignore that, which means that the curves are not being oh, separating bundles is kind of a nested procedure. Interesting. Okay, we don't need any of that. And we could just go and separate the curves. So separate components. Into there, plug you into there. Why are there two? We don't need two. I'm going, like, most likely a lot of this was here for a reason, but I am just playing around with it. Let's go and take a excusez-moi. Okay. Oh, was mesh just not connected? Evidently not. Oh, and those are meshes, not curves. Oh. That explains a lot. Okay, so that was there for a reason. But we're just going to ignore that for now, so we're just going to delete all of that. Nice. The pinned rope. We got the start point there. We got the rope here, which I don't know what that does. Resample curve. Oh, wait, no, those are curves. Separate geometry, separate components. I would assume. Oh, they are all instances. Okay. So just, I just need to go and curve to mesh. So in theory, and that does not work. Oh, no, wait, it is working. Okay. There we go. So a bit simpler, but it still works as I intend. We can see that that's working just fine. XPBD working, and then the solver in here. Let's go and extract that so that we have it again without any levels, or as few levels as possible. We still have the soft body, which is doing all of that, which is good. We have that, which is doing good. And we could go and just put the compliance into there, but I don't think we need to edit that. The substeps are set to 40, which is a bit high. Let's just set that to be 10, you know? Seems to be fine. Runs a bit faster. Go and hide all of that. We just separate the instances, put that into there, and that should be good. Okay. Will this eventually be accelerated by GPU? Most likely not. Most likely not. Let's see. As far as I know, all nodes and geonodes are CPU. Yes, every single one runs on the CPU because, you know, not every workflow is compatible with the GPU. Okay, so I guess the question is, if we have a soft body, can I pin the ends? Not sure. Physics pin constraint, combine bundle, and then there's a length constraint. Physics point body. So in theory, body. Maybe I should have kept that infinite plane. Or ground physics ground plane. Yeah, let's just we can keep you around for a little bit. There we go. Okay. So now they are colliding with the floor, which is represented by nothing because it's just math. You can see that that works quite well. Okay. I mean, yep, that seems to work quite well. Now, I did hear that there was a rotation attribute. And I don't know. Separate bundle. And that's not automatically outputting all the data. What do you have inside of you? Rope, cloth, and then soft body 1. Let's go and extract the... I do this without the names. Actually, wait a second. Ah, yes, they are. Nice. Okay. So we can extract that because it has all that. Yep. Then we can use another separate bundle. Plug you into. What else is inside you? No, not evaluated. Okay. Let's go and refresh you. Okay. So as that, the body, that, and the pin constraints. So if I take it out another level and then refresh, okay, we have that. And then if we do another level, oh no, that's the limit. Okay. Press sync for bundle nodes in the end panel to create the names automatically. Yes, thank you. We have all that, and we can separate that. We can separate the body length constraints and then all that. So if I were to take a look at all of this, let's go and do that. Updates. Plug that into there, plug that into there. Okay, so this is all the data we have on hand. We have the type, the geometry, the mass attribute, the velocity. So I guess in a way this is like the store named attribute in a sense, except line and socket based instead of teleport or portal to values. Separate bundle, selection, position, filter, type. Though I do wonder... Ah, no, it's probably fine. Let's see. So we have all that at our disposal. So what was I looking for again? I wanted to get the rotations, but it doesn't seem like those are available at this time because, unfortunately, I got the wrong one here. So that one's the body. Possible to directly get that stuff? The levels still confuse me a little bit. So you have a body, then we have the pin constraint, which is the same. We have that, then we have the combines. Okay, so we have the position, the filter, the type, and all of that. And then the velocity attributes, which is just the name. So that means that I can just straight up get the velocity there. The instance transform, the pin, the velocity, the rest length. Okay, it doesn't appear that there is a rotation attribute with right here. Okay. What that does mean, we can take a look and see the velocities, which is very nice. Even on the cloth, if we move this around, we can see that that works as intended. Again, I assume, yeah, no, that's definitely delta time based. So yep, if we want that, we can do it. Yeah, oh wait, I need to go back and extract all the data. Okay, let me just keep that there. Let's go and run over to the hair solver. So let's go open recent. Let's go to the hair solver test and take a look at what delicious data we can get from there. So again, the solver here, let's just do the simplification pass. Again, these demo files are up on the PR page, so that will be fine. Do we really need the ground plane? Nah, it's fine. It's grand. Let's go and put that into there. There's no more object there, so we don't need to worry about that. Let's go and... those are our curves, so let's go and put that into a frame. We could go and join those before putting them into there. Again, trying to make this a very nice and stepped approach so that we don't need to worry about anything else. Let's go and... if these had a refresh, well, never mind. Here we go, so we have the rigid bodies. The bottom rigid body is not needed whatsoever. The ground plane is fine, even though it's not used anymore, so we can go chop that out there. There we go, bing bang boom. Now we have a very nice nested setup. I know I'm talking fast, but my brain is going super fast at the moment. And we are, how long have I been streaming for? Because we're over an hour, okay. Almost on the dot. I just had a feeling. Okay, debug curve variables. Okay, that's as intended, and as we can see, I broke everything. Okay. Do-do-do. 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 Nope, wrong one. Do-do-do. Nope. Okay. Transform contact points to object space. Okay. That one and then that. Okay. Subshape ID 1. Anyway, we can take a look at that in the future. Go. So it seems like that bundle. Okay, so some of these are clipped. And they don't want to update outside the simulation zone. I assume that's just not really supported. NPM solver 1. Let's not get ahead of ourselves. We still need to get one solver inside of Blender 5.0. Let's not get ahead of ourselves. If our expectations are too high, they will just be crushed. Let's see. I am liking how the setup is now, because the bundles are really helping keep things organized. Okay, so let's go and extract everything and try to get that data. So let's go and use get bundle geometries, which I love this node. It's so convenient. So we have all that, and let's take a look at the data we have available, which is a lot apparently. Okay, yes, we do have all the yummy data. So if we were to go and instance on points, we can go and use that data for that, and then we can instance some cubes, or like with the debug. Oh my goodness. Okay, I was not expecting that. Let's just go and ignore that, pretend I never saw it. Cube, let's go and put that into there, because we're doing this our own way. You can see that the cubes are having a whale of a time, way bigger than they should be. And then if we do that, we can see that the rotation works as intended, which means that... oh yeah, that means I could do so much here. That means I can put this on my, yeah, no, this means I can go and set up my, geometry node-based armature system again. And it'll work perfectly. With collisions. Oh, yes, yeah. I forgot, I actually have projects that I can use this on. Let's go and just chop out all this and just take a look at this. So again, we have rotation, we have angular velocity, the regular velocity, and oh yeah, angular velocity, I keep forgetting that's just a regular old vector. Instance transform, I'm not sure what that's about. Oh wait, no, I do know because instances. Duh. Okay, we have the rest length, the rotation, the inertia, then the rest shape, and then all that. Let's take a look at the velocity, see how that looks. It's beautiful. Wonderful dyed hair. But yep, that's grand for the rotations. If we go and get the angular velocity, we can see that those, yep, that's working as intended. Those seem to be stable for the most part. Yep, looks good to me. Let's go and get the rotations, take a look at them as a vector. Yep, all that seems to be good. As the Cartesian caramel stamp of approval. We can get all the data. Bring the horse with the hair. Yes, thank you for reminding me. Let's go and bring that. That will be super heavy, but by golly, we're gonna try it. Okay, so please wait while I remember what file I stored that in. Yeah, that was a 2025 project, right? Let me go and get that. I still have my projects from 2016 to 2025, which means that I'm coming up on a decade of Blender projects I've had saved. I've been doing this for too long. Okay, where did I keep the horse? Let's search for hair. This will take a quick moment. Okay, for hair setup, open it in Blender 4.5. Even though that was made in Blender 4.3. And take a look, where are you? That is the wrong one. That is not a horse. That does not look like a horse. Open, don't save. Nope, that's the wrong one as well. Where did I put the horse? Sorry everyone, while I go and look for a horse. Nope, that's Blender Blatro. Close, but not quite. Close, but not quite. Simulation. There's the horse. I have found the horse. This is taking a while to load. Oh god. And it's... Oh, wait, why are you broken? Oh no. Shoot. Well, I'm not going to worry about that. Let's just go and bring it in and worry about the consequences later. Okay, 3, 2, 1, don't save. Back to here. Okay, so we have our horse, and the fur is completely broken. Let's go. I think it's probably because the bake went bye-bye. Yeah, that seems to be the case. Let's go and bake this in its current... Dang it. Okay, what has gone awry? We have the guides, so those two are fine. We have the deformation, that is fine. We have that, which is definitely not fine, because I've... Oh, wait a minute, I can apply the rope to... Oh, no, 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 no. Oh, this is grand, I think. Maybe. I'm not sure. Yeah, so something broke in the conversion to 4.5. So for the sim here, I just need to go and take solver, which is the hair curves. And see the tangent and normal go into the rotation. The rotation gets stored and all that's fine. Okay. Okay. So we're only going to use the guides in this case, so let's only go and output those. And then we can apply them to the main after the fact. Okay, let's go and bring our curves into here instead of the monkey. So let's go and switch this to the object to curves. Let's go and chop out you and only have that. So again, trying to make this as simple as possible. Let's go and pray that this works. Yes, it does. It is laggy just because we have a ton of points on the curve. Wait, what? Ah. I forgot about that. We'll keep that around. But there are way too many points on these curves. Because, again, EV rendering of curves is not accurate yet. Again, additional subdivisions, if we do that, yeah. That will be changed in the near future, as far as I know, because the devs are working on that. Okay. Yeah, so I need to resample the curves, make them a little bit less, Let's go, make sure this is back to square one. Curves are 20, let's switch it to be 10, go and rebake the setup here, and let's go and hide the main curves. So here, yep, the horse has fur. Yay! Compliance is a little bit low, so let's go and turn up the compliance. There we have physics, gravity, drag, and then target force, which there should be no target force, so let's go and check that out. Let's see, density map to not have hair on the eyes. Yeah, well, the main thing was getting the fur to work. But yeah, that is That's for the future. Because again, one of my previous employment opportunities was to do hair simulation in a version of Blender that did not really support it. And that is, again, that was shown in theaters, which we got by with that. I am shocked that it actually worked, but it did. So it's nice to see that we're getting the good stuff. Yes, though the compliance, putting it to be too high. How do I make it so that what kind of a word is that? That's the rod length constraint. Is there a way to initialize, okay, and then capture that. Fixed rotation constraint, so that's the orientation. Is there a option to make it so that I'll try to go back to the original? Not sure. But what we do need is to potentially grab the rigid body and put it into the colliders. This might be a big mistake. This might lack a ton. Is it working? Or are you working? And that's a convex hull, which is inaccurate in our cases. So yes, right here we have our colliders right there. That seems to work just fine. And that's, oh, it's set to box. Do they interact? I cannot tell. No, they are not. Which... animated... Okay. So I'm assuming that that part just isn't fully supported. Oh, my eyes are... I'm squinting at the screen quite a bit, so my eyes are hurt. Oh, and I realized it's not a toggle window full screen. There we go. Okay, let me read the chat to make sure I didn't miss anything. Let's see. Is there fluid or rigid body in that branch? No fluid. Unless you want to use the XPBD thing to make your own part fluid simulation, which in theory is potentially possible. Great time for snap to near surface in post. Yeah, that would be extremely painful. Though, again, if you have the Mesh SDF, which, shameless plug, is in my everyday geometry node asset pack for free on my Gumroad page. Go get it, it's good. But just yesterday, a friend was having some problems with getting, you know, proper surface collisions in a sense. So if you just have this, you'll be able to do it. It's great, it's lovely, go get it. Because we can get the normal and the distance, so if it's inside the object, you can just say, hey, move it outside using the distance and the normal. But yes, we could do that, but I am very, 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 very scared of it. Now, I don't know if these forces are dynamic, but hopefully I could just do that. Where is the gravity? Can I go in reverse gravity live? Yes, we can. Oh, good. Whew. Crisis averted. So I guess we could turn off the filter, plug you into there, and then just say, hey, let's go and max the distance so that, actually no, it needs to be min, so we choose the minimum. Scale the normal by that force. Again, if it's inside the mesh, it'll actually go and do something. So in this case, we need no colliders. Those are fine. Let's go and bring in our horse. There we go. Set to be relative. Bing, bang, boom. We need to scale this by delta time. 20. Or wait. What is it again? 24. Does that work? Or wait a minute. I am forgetting. It should just be that, right? In theory, you love to see it. It's so great. You love to see it. Incredible. 10 out of 10. No notes. It seems to be inaccurate. So why is that? Do I need to reverse this? Just dunk, 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 dunk. Should just be a scale node. Let's see. SDF nodes are coming. Yeah, they are already in experimental. Oh, yeah, this is not to be confused with the grid SDFs. These are mainly used to get a signed distance field from a mesh on points, which maybe this can work on the grid. I did try it with the volume cube and that did work. But yeah, this is different than those ones. Yep. Yeah, we have that, but why is it trying to target something that is much smaller? Why? Let's go and set the scale to be -24. What is up with that? It should be doing the opposite. Should not affect any of these when they're outside. So maybe position is not having a grand old time. Position. Okay, we're at an hour and 15 minutes, and I feel like my voice is going a little bit, so I will need to, unfortunately, end the stream soon. Here's the rest, shape that, and then... I know, it's just regular old position, so you should be functioning as I intend. Why are you not? What's going on? What's wrong? We have the normal and the distance, and then the collision offset, but I'm doing this manually on purpose. The min and then the max. Let me just switch this and then... Yeah, no. I mean, it should be fine, right? If I just plug this into our quote-unquote gravity. Yeah, it's being attracted towards the center. So for some reason, it's not responding to the mesh properly. Huh. Oh, wait, and this is an old mesh SDF. Wait, why doesn't it have the other options? Where did this get pulled from? Yeah, no, this is the one I should be using, so maybe that one's broken. Yeah, that's the wrong one. Maybe I still have a little ghost in my sub? But with this one, you can do edges, faces, and all that. No, it's still not working. I don't want to spend too much time on it. Yeah, that is really freaking weird. Let me try some simple logic. If it's greater than, let's say, yeah, our... Oh, my eyes. Separate X, Y, Z. If it's greater than Y, whatever, then we will switch thing. I'm assuming that something is wrong. Let's take out the target. Oh, maybe that was what was happening. Maybe it was working. Yeah. Okay, yeah, no, it was working, just that was, I forgot to just chop that out. Yeah, let's chop out all of it, besides what's 100% necessary. So, that is using the minimum, so if it's inside, it will be moved outside, correct? It at least kind of looks like it's working. And that's like that, so it should be the amount per frame. If I am correct. Let's go and add in some gravity, just so that we can change, or test that. This should be 9.8 meters per second. Does that even need to be like that? I love collisions. They're fast and not slow whatsoever. I love it. It looks amazing. Let's check on the inside. No, it's still freaking out. Huh. That's really freaking weird. Maybe it needs a couple of sub-steps, potentially. Let's set this to be an absurd value so that anything on the... Yeah, okay. Anything on the inside just gets jettisoned to the outside. 24 times 24. Maybe it just needs to be that. 24 to the power of 2. Look inside and... I mean, it is being moved out. I know that. In theory, it's working. Practice, not so much. But I hope when XPBD comes out, it'll have a proper mesh collider that is much faster than this, because this is atrocious. I would not want to work with this. And it's all, like, again, this is the optimized hair. Just the guides, and it's running like it's 2004. I guess gravity might not be the right force here since it's not per point. Gravity not per point. I'm assuming that this is just a wrapper for, yeah. This is per point. From this test, we can see that it does take into account what is there versus over there. So that's fine. It is working. Just very subdued. And since it's not actually, like, internal, that's probably a reason why. But yes. Anyway, I think that's good for now. So we can see it'll work. The only problem is that collisions are still a pain in the buttocks. Take the SDF with a bake node. Well, the SDF updates every single frame. So we can't exactly do that. We would have to bake the entire simulation, essentially. Because this doesn't go to a grid. This is not a grid. Each point references the mesh based off that, because internally it's just using geometry proximity for all those, and then sample nearest surface. Wait a minute, why is that using sample? Oh, right, never mind. I know why that's happening internally. But yep, that is what's going on. So without it, we can see that we're still getting a very crisp 12 frames per second, which is less than ideal. Oh, we're doing 50 substeps. That explains it. There we go. So if we do this, we should get yeah, it's around the same performance. Because I assume with every single substep, it's recalculate. Is that what I need to do? Because since there's no real geometry here, how would I go and capture this attribute without it like being recalculated for every single substep? I don't know. Yeah, I don't know how to actually do that. Because, yeah, no, I think that's the only way to do it in reality. Because the length, yeah, okay. So the length constraints and the collision constraints are both together. They're not separated. So we can't make it so that the hair will just stay the same length and then do like 1 or 2 or 3 collision steps per frame. Since they're all just completely combined, you can't have one without the other, so it'll just be slow. Which is unfortunate. But yeah. Alright. Let's go back to the rigid body. Do I save this in its current? Yeah, let's just save that in its current state. Let's go back to the Jolt solver. Because again, this one is presumably the fastest in the world. Maybe with the exception of... Oh, what was the other one? AVDB or something like that? This is the one, the tried and true method used by game engines the world over, and yada yada yada. Yeah. This one's cool. Really cool. Not that the XPBD one isn't cool. That one is still very cool as well. But it is interesting seeing Jolt in here. And then Box 2D is interesting as well. But I'd say the workflow that we're seeing here is viable. Vertex block descent. Yeah, augmented. Yeah, I saw that. Apparently that one's new. Now, I'm not entirely for hopping on the newest train of, oh, what's the new solver that's out and about, and then implementing that into Blender. I would say if the solver is like 5 years old, then you know, I'd say that one's good. Like, not to be afraid of the new stuff, but, you know, the tried and true methods are tried and true for a reason. Yeah. So we have that. Oh, right, that's what I wanted to do. I wanted to use a noise texture on this and see what happens. Because again, we can just use simple vector math, plug it into the forces, and with something as simple as that, we should get some interesting things going on. Let's just go and crank that up to infinity. Are you working? It's trying. It's almost working. Almost. I want to get like a current going. Almost. Almost. Come on. Let's set it to... We'll need at least 10,000. There we go. Yay. Fun. There we go. That's what I was going for. You know, it's a little bit too much. Let's just go and put a little dampener on it. Let's go and set the bounciness to be a little bit higher. Maybe for... Wait, where are all the... Yes, there are my cubes. Here we go. A little bit of bounciness. Turn down the friction so that they can all slide over each other. There we go. Yep, so we can do so many things with that. Yeah. Can we go and introduce new rigid bodies? Oh, yeah, we can. Okay. So these are dynamic, not animated. So again, if we were to... I want to test this again. If they are animated, does this update? No, it does not. Okay. So again, we would have to like pseudo update that with Jolt. I don't know how to do that. But we can see that part is working as intended. Yay. Oh, that's grand. Let's go... Do we change this to be spheres? We could have any object we want on this. Let's see. Let me think about this one. I mean, we could have a monkey, we could do anything, but I feel like there's something else I can do before I end the stream. Let's see. I thought you can update the size, for example, with dynamic. Oh yeah, you can. Huh. For some reason, I probably thought that was only box 2D. But yeah, that is a... That's kind of OP, yeah. That is the instance one. So if I change the size of the actual cubes... Oh. I was like, oh shoot, did that cause a crash? But no, we can update the geometry dynamically and then that happens. So it's only... Like, the animated ones are still a little bit finicky. But yeah. Okay, let's go. Yes, that's what I wanted to do. Thank you for reminding me. Do I have a Rubik's Cube at my disposal? No. There was something that I was going to use. Okay, let's just geometry nodes this. So let's just go and have an icosphere, use some geonodes. Let's go and use a nice extrude. There we go. Let's go and use a scale elements. Or actually, no, we don't even need that. What we simply need is a noise texture for the offsets. Use a nice little map range. This can be one dimension with a nice little random because it's on the face domain. Put that right there. Use an add node. Use the scene time, multiply it, or no, that should be fine. We can just scale it if we need to. Plug it into there and we should see, yep, that's doing its thing as intended. We do that. Maybe set it to be 2. Yeah, that seems to be fine. Even, no, it's fine. There we go, something more like that. Let's go and set it to be smoother steps so we have that. So now if we were to go and put this into here, with this being convex hull, insanity will ensue and it will probably be super freaking laggy. But, could be fun. God. Let's go and turn this down to be 10 by 10. There we go. And it works! Yes! Hours and hours of my time have been resolved. Oh, you love to see it. Tears in my eyes. Let's go and scale this down. Finally, after 5 years, you can have dynamically updating shapes with the physics system. Tears in my eyes. But yeah, it's cool to see. Very cool to see. I think we can do a bit better with that Ecosphere. Let's go and tone it down by a bit. Go, put that down, put that into there. Yeah. Music has changed, which is a sign. But again, it works. You love to see it. And it is interacting with the cloth, albeit not too well, but it is, you know. We can see the bake change. I do wonder how heavy the bakes will be with the geometry, like the source updating every single frame. But I would expect it to be the same as anything else. But yep. With everything else, like the instance placement is like that. Where can I download this build? Well, you cannot download it yet because the Windows build is still broken on BuildBot. But if you build Blender yourself, you can build it. And it works. But yes, there we go. We can change the scale, which, oh my god, I am amazed that that actually works. Yeah, so what else do I do with this? 5x5, just to have a few of these. Yeah, we now just have it. It works. I could have a Rubik's Cube. Oh, wait, I just remembered. Be right back. I can go and pull, what was it? Some sort of cube that would split itself in half and rotate that I made like in Blender 3.6. Let me check my files. Fractal circle pattern. Nope. Cell fracture demo. Sim cell fracture Rubik's Cube. Yes, that's the one I wanted. Just chilling, just waiting for it to load. After 3 years. Yes. Okay. Copy objects. Paste objects. Close out of the other file. Save that. Go back to the Windows scene. There we go. Okay, so here we have a cube. It's a trick cube. It's a special cube. This cube splits and rotates. And, oh shoot, it's broken. Classic. No, we don't need that, because again, this was from Blender 3.6. Very, very old. We don't need you, so again, let's try to reset it. And actually, since we have manifold now, this should be much better, in theory. Nope, it's still doing just fine and breaking and annoying the ever-living out of me. What's wrong? What's wrong with you, buddy? We're working. Why did you stop working? I just need to... Let's just turn off the snapping. What is wrong with you? Should I just remake it from scratch? I think that might be the thing to do. Let's use a rotate vector instead of that, so that we can just plug you into there for the axis. This angle to rotation. It's rotating the position. Weird. Yeah, I probably should remake this, because it's, might be old. And out, chop you out, put you over to there, yeah. The material inside the simulation zone, you know I was testing that way back when. Yeah, let's, yeah, no, it's just broken. Okay, well, anyway. Let's go and try to do a quick fix with it, see what the hell is wrong. We put that into there. What's the matter, buddy? The input not oh, wait, what? I have this just the wrong way around. Yes, I do. Not manifold. So again, right here. I know that's working as intended. That one's working as intended. So I just need to scale it down a little bit. That might be the solution. Scale elements. 0.999. Eh? It has to be you. Has to be. So it's the select one part. But shouldn't I just be able to... if your position is greater than the rotation axis? And the position, because I have that? Yeah, no, I should just be able to do that. Okay, intersecting edges. No, we don't need you. You are you. That's only for the shader. Take all of that out. And... huh? I am honestly a little bit confused as to what I was thinking at this time. Not the most foreign concept to me, but... okay, that's not moving anything. Will rotate thing should just be if your position is greater than that position and aligned with the rotation. So just a dot product with the position minus the actual position. You know, I should have probably just made this from scratch. I hope you're all enjoying it. The stream is going to be a long one. Are you working now? No, you are not. Dang it. Let's see if the... oh. Uh-huh. Uh-huh. I'm greatly confused. Okay. Let's just delete all this and again start basically from scratch, but not entirely. Select one part. So yeah, I could just store the will rotate named attribute on there, but I have a gut feeling that it's not working as intended. Well, let's go and try it. So store named attribute. This will be just a boolean, which will be rotate, yeah, will rotate like I had before. Again, I should not be using capitals, but that's how Blender does it, and that's how I got the habit. That's fine, that's fine. The position is stored right there, and that should be the position there for the rotation, yep. All that checks out, so just will rotate, put it in there. That one should have a value of 0. I need to, dang, yeah, what the heck is going on here? Every once in a while, it'll just go and do that, yeah. There should be a... integer map? Wrap? Oh, wait. Oh, there's no wrap in there, huh? How about that? I guess it could just be modulo. Then I plug that into there. No, okay, no, I'm just not gonna... versions, yeah, what the hell is, up with this? Let's go and not affect the position whatsoever, and only... here, I'm gonna go back to the old music, because it's probably a bit loud. Ah, there we go, very nice. We'll rotate. Take a look there, take a look there. Yeah, no, that is being stored, so that's not the problem. Okay, so it's the rotation. So let's just go and chop all that out. Let's make sure our data is correct. So again, rotation. Go. Is this updating? Okay, that is updating. So the rotation of the plane is that. It's not being snapped. So that's good. Why do I have that doing that? I don't know. Probably fine. Or actually, yeah, let's reduce the amount of nodes. That's the goal. So we have that and that. Both of those are being stored on the geo. Uh-huh. This is going again. So fun. We just stored the position and rotation. Almost as if they're constants, but they need to be saved for the next frames. And right here, we got that. Yeah, no, this should be super simple. I don't know why I was having problems with it. Here we have that and that. So for the position, let's go and make sure this is correct. We will go and rotate, vector rotate, because we need the center. This node is more convenient than the newer one, I'm sorry to say. So here we will use the position. Do this. So again, that's the center. I'll make it so that it rotates by a little bit every single time. It should be rotating. Yeah. Sorry, everyone. I thought this would be simpler. Set position. Just go and reset that, just in case. Geometry is going in there. Well, yep, I guess the position is working. Just, oh, dang it. Yeah, someone just pointed that out in the chat. My hubris has caught up to me once again. Good, that's working. Nice. Okay, so we have the position, that's fine. The position should be where the cutting plane actually is. Yes. And the rotation is where the cutting plane is rotated to. Or this will be, I guess, no, this will, selection. Yes, I'll just label this selection so that I cannot confuse it whatsoever. With that, and then if we just plug this into the Euler rotation, this won't work, but I just want to try. Okay, yep. So we need an axis and an angle. So axis angle, let's use a vector rotate. Or no, rotate vector. Plug you into there, set you to be Z, plug you into there, and we should see. Okay, good. What was its frickin' problem? Are you working? Yay, you're working, okay. Okay, now with that humongous detour out of the way. That, yeah, it is what it is. Not too happy with how the spaghetti is working there. Since when was there an invert on that node? Oh well. So position goes right there, right there, right there, and so on. Let's see. That's fine. So we just store those. Okay, that's good. And then I can just store the intersecting edges, and that'll be fine for when shaders work again. Okay, that's good. We can snap the rotation again. In theory, if it did not just disappear. Meh. Okay, let's just go and scale elements because I cannot be bothered, so 0.999. Nope. Still gets yeeted away. Let's just go, okay. I've spent too much time on this, sorry everyone. Okay. So the location is still an issue because that can happen. So I thought it wouldn't be that bad. Maybe I do need to just attribute statistic center, which yeah, that wouldn't be bad. Attribute statistic, throw that into a vector, position, lug that into the center, but maybe still give it a little bit of a boost. A little bit of randomness never hurt anyone. So let's go to, yeah, we go and plug that into there. Oh, lovely. Love to see it. There we go. So if we do that, again, try to stay somewhat centered. So maybe 0.1. There we go. That's a bit better. There we go. Good. So with that, 100% necessary and totally not just something I should have remade from scratch detour out of the way. There we go. This should be a node group, but I can't be bothered at this time. There we go. Yeah, good. Good. You love to see it. Okay, with all of that out of the way now, we can just do, donk donk. And now we can see that, hey, the parts move and it works. Though the friction should be quite a bit higher. Yeah, and let's just have, 1. I guess 2. So there we go. It's rotating, it's moving. Velocities don't seem to be accounted for, but that's fine. That's fine. Even though, if I stored the previous position, which in this case I don't think I can because the topology is being completely obliterated, yeah. I could potentially make that influence the instance, but not at this time. It's fine. Okay. So, I guess this is the end of the stream. A lot longer than I wanted it to be, but hey, we have stuff to experiment with. Thank you all for watching. I hope you all enjoyed, and I will see you next time. Have a good one. And also thank you to the devs for fixing the build. I'm very happy with that. This build is very cool. Again, it's experimental. Not sure if it will be in Blender 5.0 or the most realistic expectation is for it to be like the NPR branch. Parts of it may be taken and put into a future version of Blender, maybe 5.0, maybe later, who knows. But this is a very cool experiment. So, thank you all for watching, and I will see you next time. Have a good one.